linear inequalities. Same on linear inequalities, that if you are given, you are asked to draw and to shade the region. If you are asked to draw and shade the region, then what you need to do is to look at the inequalities. You need to look at the inequalities. So let's have this as our example. Number 3, you're told to draw the region enclosed by the lines x greater than 0, and then x, that is y greater than or equal to x, and y greater than or equal to 0. So we need to draw the region that is enclosed by those 3. When you draw this, what you need to know is these are general straight lines. We have the line x greater than 0, that is now on the y-axis, and this is 0. This is the x-axis. So the line greater than 0, x, if this side is -1, this is 1, 2, 3, 1, 2, 3, -1, -2, -2. Then the line x greater than 0, this is the y-axis. So the values greater than 0 are on this side. So we shade the opposite side. I will shade on this side. But remember, it is strictly greater than 0. So what it means then, this line ought to be dotted line. This line ought to be a dotted line. The second line, with y greater than x. So the line y is equals to x. We all know it is the line through the origin, sloping in this case. But now, because the inequality is greater than or equal to, then this line ought to be a continuous line. So it should be a continuous straight line through the origin. Now, which side is greater? If we test, maybe for example, take this point 2 and 1. This is 2, 1. Where x is 2 and y is 1. And replace it here. Y will be 2, y will be 1, x will be 2. If you compare 1 and 2, 1 is less than 2. So what you need to do is we shall shade this side. We shall shade that side. So we'll have, okay. So we have y greater than or equal to x. And then we go to the other line, which is y greater than 0. That is the x-axis. Now we shade this side. Again, the line has to be continuous. So this is y greater than or equal to 0. So if you look at this shading, there is no defined region. No defined region. So what you need to do is, we go back to the inequality y greater than x and have this as y less than x or equal to x. So if that then becomes now we shade now the opposite side. So we'll now have this, but now we'll shade this opposite side because it's supposed to be less than or equal to x. And then we add another line, assuming we have x less than 4. Then that means on the x-axis, identify where there is 4 and draw a vertical line through x is equals to 4, again dotted, and the values of x less than 4 will be on this side. So this is x less than 4. So that now we become with a region R. We've only changed this so that we can obtain a defined region based on the inequalities that we have. That x greater than 0, y less than or equal to x greater than or equal to 0, and x less than 4. So those are just simple things that you can try and look at them when you're drawing the inequalities that defines a given region. So let's look at some of the questions that have been tested in this topic from the previous KCC questions. So as you can see on your screen, you are told to solve the inequality. You are told to solve the inequality. And the inequality is 2x less 1 less than or equal to 3x plus 4 less than 7 minus x. Less than 7 minus x. That's the first question that we need to look at. Okay, this is in KCC 2019. So during this, if you're given this kind of a case, as it was tested last year, then we have to obtain a simple inequality from this. And we said we start from the beginning to where the second inequality sign starts from. So you'll have 2x less 1 less than or equal to 3x plus 4. And then again, from the last up to where the second inequality from that side begins, so you have 3x plus 4 less than 7 minus x. Then once you have this, you collect like terms from each. So this becomes our 1, and this is our 2. Solving 1, we have 2x less 1 less than or equal to 3x plus 4. I will collect like terms. This becomes negative x. Take negative 1 to the right side, less than or equal to 5. Something good here, when you divide by negative 1, anytime you divide by a negative or you multiply by negative, the inequality sign changes. So now it becomes x greater than or equal to negative 5. Then we solve for 2. Solving 2. 3x plus 4 less than 7 minus x. Again, collect like terms. Negative x to this side becomes positive. So this is 4x. And this to the right side, negative, less than 3. So over 4, this cancelled. So we have x less than 3 over 4, or x less than 0.75. Those will be the solutions for this. And this was awarded 3 marks. And you can see how easy it is to solve. Let's look at the next question. Next question. In the next question, it's a word equation. And so what we are told is that a school, that is a school, decided to buy at least 32 bags of maize and beans. A school decided to buy at least 32 bags of maize and beans. The number of bags of maize, were to be more than 20. More than 20. And then and the bags of beans were to be at least 6. The bags of beans were to be at least 6. Then a bag of maize cost 2,500. The bag of beans cost 3,500. And the school had a total of 100,000 to spend. A total of 100,000 to spend. Then you are told to write the inequalities. So how do we work it out? A school is buying 2 products here. We have maize and beans. We are not sure what are the bags of maize that were bought and what were the bags of beans that were bought. So let's have X bags of maize and let's have Y bags of beans. So if we are buying X bags of maize, and in total we need to have at least 32. At least here means 32 or more. And so when you write, it means X plus Y should be greater than or equal to 32. That will be our first inequality, which is now bringing together the number of bags of maize and the number of bags of beans. The number of bags of maize is supposed to be more than 20. So that means X should strictly be greater than 20. And the number of bags of beans should be at least 6. That is now Y greater than or equal to 6. But we are told that the price for 1 bag of maize is 2,500. So the total cost will be, we are buying X bags of maize. That will now give us 2,500X, and Y bags of beans, a total of 3,500Y, to give us a total of 100,000. So the school cannot spend more than 100,000. So this cost should be less than or equal to 100,000. Then we simplify this, cancel out. Dividing by 5, that gives us 5x plus 7y less than or equal to 200. So these are the 4 inequalities. The first one, the second one, the third inequality, and the fourth inequality. And that question was 4 marks. So for each of the inequality, you score 1 mark. Next question. The next question, that is in 2014. In 2014, students were asked to solve. They were asked to solve the inequality, which is 4x less than or equal to 3x less than 2 less than 9 add x. Then they were to list the integral values of x. So that is for 2014. So let's solve together. We again, just as we dealt with the 2019 case, we extract 2 inequalities here. So we have 4x less than or equal to 3x less than 2, and solve 3x less than 2, that's less than 2 less than 9 plus x. This becomes our 1, this becomes our 2. So we'll have 4x less or equal to 3x minus 2. We collect like terms. To this side becomes minus. So this x less than or equal to negative 2 as our first solution. For this other one, 3x less 2 less 9 plus x. Take the x to the left side, negative 2 to the right side. So this gives us 2x less than, and then that gives us 11 Therefore, x less than 11 over 2, which is 5.5. So these are two solutions, the first one and the second one. But we need to give what we call integral values. Integral values are supposed to be non-decimal. So in the case we have decimal values, we shall have to round them off. Now, looking at these two cases, x is less than negative 2. X is less than negative 2. And again, x is less than 5.5. X is less than 5.5. I think we have a change in the inequality. This is greater. This sign here is greater or equal to. This should be greater than or equal to, sorry for that. So that we have, this is greater or equal to. So x is greater than or equal to negative 2. And then the other one, x is less than 5.5. So the values of x, the integral values of x now will be, we use the curly bracket. If x is greater than negative 2 or equal to, the negative 2 is one of the solution. Then we go to negative 1, 0, 1, 2, 3, 4, and 5. Because it's supposed to be less than 5.5, and the nearest whole number to 5.5 is 5. So those will become the list of integral values of x. Okay, so those are few questions that we can look at in the previous exams. So let's look at the last one. That is in 2013.